Welcome back for lesson 24.3. Today we're going to be solving log equations. So make sure you have your Springboard book. We're on page 376. Need something to write with and definitely a calculator to help you solve some of those equations. All right, so equations involving logarithms of variable expressions are called log equations. So basically it's a log function. It just happens as an x or an equation in the middle of the problem. Okay. Now, because log equations have a restricted domain, remember when we did the domain for these problems, it was always our asymptote. So let's say like our asymptote would be like 1. It was always like our asymptote to infinity when we did the domain. That's because our domain is restricted. It has that vertical asymptote somewhere on the graph. Okay? So because of that, we have what's called extraneous solutions. So we'll try to get to some examples where we see that. But let's just talk about first how to solve these exponential equations. Or I'm sorry, these log equations. Okay, so what we're going to do is we're always going to start by isolating our log expression first. Now this one didn't have anything around the log expression, so we didn't have to worry about it. But in a couple of the examples down here, we will see that. Okay, now we did talk about inverse functions with logs. Now the opposite of a log function is an exponential. So you see how they're writing in an exponential form. We're just going to rewrite the log, okay? We're not going to really do it how they have it in the book. We're just going to rewrite it as an exponential problem. Then we might have to do a little exponent work where that's where your calculator is going to come in, okay? And then for these, we do want to check our answers to make sure it's not extraneous. But let's start with A here. So we have log base 3 of x minus 1 is equal to 5. So there's nothing around the log that really have to worry about. So what we're going to do is just start by rewriting this as an exponential statement. So that would become 3, remember it's 3 to the 5th power, is equal to x minus 1. So it's always your base equal to the exponent. So your base to the power equal to whatever's with the log. Now we just have to do a little exponential work here. We have 3 to the 5th power. Just plug that in our calculator. So 3 to the 5th power is 243. 243 is equal to x minus 1. So then the last thing we would have to do is just solve for x by adding that 1 to the other side. So our final answer here for x is 244. Okay. And there you go. So all you're going to do is take your log expression, rewrite it. Remember, it's always, if we have log base b of n equals m, we can rewrite that as our base to the m power equal to n. Okay, so you rewrite it as an exponential because that's the inverse of a log, and then just solve what's left. So I'm going to have you guys actually try b. You're going to rewrite this as 2 to the 3rd power is equal to 2x minus 3, and then simplify everything after that. So go ahead and try b. Do it exactly as I did problem A. Okay, here's what I got. So I rewrote it as an exponential. 2 to the 3rd power is equal to 2x minus 3. Now 2 to the 3rd power is 8. And then after that, we just have a little two-step equation. So it doesn't work out to be a nice number, but we get 11 halves, okay, or 5.5. All right, let me go over C really quick, because C, our log is not by itself. Okay, you can see the log has a little coefficient in front first. So what we have to do is isolate that log. So I'm going to divide the 4 out on both sides. So that's going to give me the natural log of 3x. Okay, 8 divided by 4 is 2. So since this one is a natural log, we need to rewrite it using base e. Remember, this is our special log. So this becomes e to the 2nd power is equal to 3x. Now, anytime we're working with e, we're going to have not nice answers, because remember, e is a not nice decimal. So what we're going to do is just take e. Remember, it's above the division sign. So e squared. I got this decimal, 7.38. And then to get x by itself, I would just have to divide it out the 3 in front. So I'm just going to do this all in my calculator. That way I don't have to write down more than I need. But final answer here, let's say 2.46. So 2.46. So anytime we're working with e, you are going to get a decimal answer, and that's okay. But remember, natural log's base is e, so rewrite it using e as the base, and then solve from there. So the rest of this I just did in my calculator. All right? Now the second type of examples we're going to see is if we have a log equal to a log. And this is similar to when we did the exponential equations, when we had a base equal to a base. So if you have a log equal to a log, essentially you just drop the logs and just equal the two things inside the parentheses. Okay, so let me show you an example like that on the next page. So here's the example from your book, but I'm actually going to do example B here. Now A is not a log equal to a log, so you guys can solve that one like we did on the last page. And C I'm going to cross off for right now. But let's look at example B. So according to our property here, if we have logs of the same base on both sides, which we do, we have log base 5 equal to a log base 5, then we can drop the logs and just equal the two parentheses. So I'm going to drop the logs, 7x minus 2 equal to 3x plus 6. Okay, and then we just solve this equation like normal. So I'm going to move my x's to the left side. That becomes 4x. Move my constants to the other. I'm going to add the 2 over, so that's 8. So it looks like we get our final answer of x is 2. Okay. So again, if you have a log equal to a log, you just drop the logs and equal what's left over. So I'm going to have you guys try one of these. Now this one was not in your book originally. I just included it. But go ahead and try this one. You have log of 3n plus 10 equal to log of 2n plus 8. So again, if you have log equal to a log, you just drop the logs and equal your two parentheses. So go ahead and solve for n on this one. See what you get. Okay, if you did it correctly, you should have got negative 2. Okay, so we would set it up. We would just take 3n plus 10 and equal it to 2n plus 8. So if you do that, you get your n's on one side, constants on the other. You get n is negative 2. Okay. All right, one last example that we have to look at is when we need to use log properties. Sometimes it's necessary to use properties of logarithms to simplify one side of the equation before solving. So you see how this problem has 2 logs on the left side? What we're going to do is condense the log first using those log properties. Now addition turns to multiplication. So you see they multiplied that, x times x plus 2. And then they use exponentials to rewrite the formula. And then they can solve for x. Okay? So let me show you some examples. I'm going to go through A really quick with you. Now in A we have division. Division turns to what operation? Well, division would turn to subtraction. So what I'm going to do is turn this into a single log. So log base 4, okay, of x plus 6 divided by x, because we have subtraction. So when we condense it, that turns to division. Okay, and that's equal to 2. Okay. Now I'm going to rewrite this using exponentials. So my base is 4. So 4 to the second power is equal to x plus 6 over x. Now we know 4 squared, that's 16. We'll run out of space here, that's okay. Is equal to x plus 6 over x. Now I want you to think of this kind of like a proportion. I'm going to put this 16 over 1, because then you can see from there we can kind of just cross multiply these and solve for x that way. So 16 times x would just be 16x. 1 times x plus 6, well 1 times anything is just that thing. So really from here we can solve this pretty quickly. Just move the x's on one side. So we get 15x equal to 6. So let's just get that decimal. 6 divided by 15. We get that x is 0.4. Now that's kind of the hardest one you would have when you have to combine things like that. But I'm going to have you guys try example B here. Now example B, we have the natural log of 2x plus 2 plus the natural log of 5 is equal to 2. So maybe I'll help you guys set up B a little bit. Sorry, my screen's going a little crazy. Example B, we have the natural log. We're going to condense this into one part. So addition turns to multiplication. So we're going to have 2x plus 2 times 5. Or it might even be easier to write it like this. Is equal to 2. Okay, so go ahead and try this one. Let's see what we get. Okay, so you're going to have to multiply 5 times 2x plus 2. Now remember, when you rewrite this as an exponential, it's base e. Okay, so go ahead and try this one. We'll see if you get it. If not, I'm going to go over it when we're done. Okay, if you did it right, I got negative 2 or 0.261. So let's go over that. So we have our base e. We're going to do e to the second power is equal to our expression here, 5 times 2x plus 2. So let's simplify this a little bit. 5 times 2x plus 2 is going to give me 10x plus 10 equal to e squared. Now the rest of this I'm going to do in my calculator, and I'll show you how. Okay, move this over just a little bit. Okay, so we need e squared, so I'm going to do e. Oops, that's pi. Let's do e squared. Hit enter. So we get this decimal, 7.39389, okay? And then we have to do our 2 steps to solve for x. Okay, so what I'm going to do is first I'm going to subtract 10. I'm going to subtract 10 on my calculator. Okay? And then we're going to have to divide out by that coefficient in front. So I'm just going to do this all in my calculator. Divide it by 10. And there's my answer. So negative 0.261. Okay, so again, I can show you my work in the calculator one more time. Okay, but all I did was do e squared, my left side, and then I just did my 2 steps in the calculator. So I subtracted 10 first, then divided by 10. Okay, so we saw 3 different types of problems today involving the log equations. One of them, the first one, is if you just have a single log. Okay, you just have to rewrite it as exponential and then solve for what's left. Okay, so the hardest part here is just doing that little exponent work, but use a calculator if you have to. The second type of equation is when you have a log equal to a log. So if that happens, we just drop the logs and equal our things in parentheses and just solve for x or n from there. And then the hardest ones is if you have to combine the logs first. So anytime you have to condense the logs, okay, if you have 2 logs on one side of the equal sign, we condense the log first. And then it's like one of our first types of problems where we have to change it into an exponential, okay, and solve from x from there. So those were our logarithm equations. We'll practice more together in class tomorrow.